Alrighty, class. Good morning or afternoon, depending on what class you are in. So as you sure have noticed, I'm obviously not going to be there today. So I wish I could be, because I think this can be kind of an enjoyable lesson for you in geometry. So you should have already gone to Blackboard and downloaded from the announcement the classwork file, which when you open it up looks something like this. Okay. You really only need to have one person in the group be able to open the file. So we've already registered this program earlier in the year, remember? So it may look familiar to you. Geometry Sketchpad, GSP, as it's written on your computer. But if you recently had something like done to your laptop from the Computer Depot, sometimes you have to kind of reinstall stuff. So don't worry about that. As long as one person in your group has it working, then you'll be fine. Okay. So basically, with your blank set of notes that you hopefully have or will be getting here soon from the substitute, you'll be kind of walking through with your group this file, looking at some parallelograms, some rhombuses, as you'll notice on the bottom tabs there, some rectangles, and then eventually get to squares. And you're going to be dealing with different properties of those shapes. Okay, so for the first one, a parallelogram, you need to go ahead and fill in your blank notes that a parallelogram is a quadrilateral with two pairs of opposite sides being parallel. Hence the name parallelogram. Okay, and what you'll notice there is that you have 4 blanks in that box. So you'll have 4 blanks in the box. And using these 3 tabs, parallelogram 1, parallelogram 2, and parallelogram 3, I want you to kind of answer those questions and fill in the properties that you notice. Okay. So for the first one here, it says to measure a side length. Remember, you click once to highlight a side, so using that arrow tool. Then you click measure and then length. Okay, so this side is 5.21. To measure the next side, click it, measure length. And then the last 2 sides here. And then I want you to basically tell me, what do you notice about the links? And you should have a property or an idea. Now I would use a pencil for this because we'll review them once you've gone through the files, okay? And it asks to move the points around, see if you notice if your conjecture holds, okay? So that's how you measure a side. For the next one, you're going to measure the lengths of the diagonals. So you're going to be looking at the little parts here. Okay. Using the same process as we did for the first one. And then for the last slide here, there's going to be 2 angles that occur with the angles. Or 2 relationships, that occur with the angles. So to measure an angle, you click the 2 sides that form the angle. So I'm trying to measure this angle right here. And click measure and then angle. So it says ABC is 119.19. If I want to measure the angle at C, I select these 2 sides. Same thing. Okay. And you should notice 2 relationships about the angles. Okay. And then you'll keep on going for rhombus, rectangle. Hopefully you'll find this story funny. You can just read that. It's not in your notes. And then finally square. Okay. So go ahead and pause the YouTube video here, and then when all of y'all are finished going through and filling out what you think the properties of a parallelogram, a rhombus, and a rectangle are, then I want you to pause and then wait for everybody to finish up, and then you can resume the YouTube video. Alright, so hopefully you were able to at least get most of the properties down. Now you may not have the properties written down exactly like I do for these, but as long as it's saying the same thing, it's your notes, that's fine. Okay. So for parallelogram, you should have noticed 4 different things happened. Okay, you should have noticed that the opposite sides were congruent. You should have noticed, and this may have been from the 3rd slide, that consecutive angles, remember those are the ones that are right beside each other, are supplementary. That the opposite angles were congruent. And then finally that the diagonals bisected each other, or they cut each other in half. If you do flashcards, which I highly suggest for this chapter, I would put properties on a parallelogram on one flashcard. Oops. Sorry. Had to get everything situated there. Alright, for the next one, you had to do a rhombus, so it's a parallelogram with all sides congruent. So you should have noticed 2 additional properties, because a rhombus is a parallelogram, so it still has those original 4 from parallelogram, plus it has diagonals or perpendicular, and the diagonals bisect the opposite angles. For a rectangle, remember it's a parallelogram with 4 right angles, and you should have had that the diagonals were congruent. And this is probably the most used property in the real world. If you're trying to make sure like a door frame is actually a rectangle, they'll take the tape measure and they'll measure the diagonals to make sure that they're congruent. If so, they know they've got a rectangle. And then all 4 diagonal pieces end up being congruent because of that. Hopefully you enjoyed the story about how we got square. So what's special about a square is it has the property of both of its parents. So it has the properties of both a rhombus and a rectangle. So it has all angles, or right angles, and all congruent sides. And we'll actually get to the rest of this next time. So under parallelograms, you should have noticed a slide or a section that said that there's a 5th way to prove that you have a parallelogram. Okay, so we clearly have the 4 properties of a parallelogram, but there's a 5th way to show that you have a parallelogram, and that is, if I can get these to move here, and that is if you have one pair of opposite sides that you know 2 things about them. You know both they are congruent and they're parallel. We'll talk about that a little bit more next time as well. So we've got some examples that we're going to be working through. Let me skip it back. Okay. So the first one on your note sheet there, so we've got parallelogram Andy. Okay. So basically you've got to use those properties to solve for the different variables. Now you're never going to have one quite this complicated, but Makes it a little bit easier on me if we've got kind of 3 examples in one here. Okay. So the first one, so we've got diagonal or opposite sides, are congruent. So 5y minus 4 equals 3y plus 2. So that means when you go to move the 3y and move the 4 over, you get 2y equals 6, so y is 3. Once you know that, you also know that the diagonals bisect each other, so that means 2y is equal to x plus 1. So that means now that we know y is 3, you've got 6 is equal to x plus 1, so x has to be 5. Alright, so for finding z, you'll notice that in maroon there we have 35 degrees and 2z plus 5 degrees. So remember, since this is a parallelogram, that means AN and DY are parallel to each other. So that means 35 and 2z plus 5 are alternate interior angles. So you gotta remember those angle pairs from way back in chapter 2, I think it was. Chapter 3. Okay. So those are equal, alternate interior angles are equal, so 35 equals 2z plus 5. That means 2z equals 30, or z equals 15. For the next example, so actually, I want you to go ahead and try the next example. Remember what you know about opposite sides in a parallelogram. Okay. And then once you've had some time to try that, then go ahead and continue on with the video. Alright, so in a parallelogram, remember opposite sides are congruent. So that means 4x plus 1 has to equal 6x minus 4. Okay. So when you go to solve for your algebra there, moving the 4x over, you've got 2x. Moving the negative 4 over, you have 5. So that means x is 2.5, 2.5. Okay. So to find the perimeter, I'd have to plug back in. So I get 4x plus 1 when I plug back in is 11. That means the opposite side is 11. 5 times 2.5 is 12.5. That means the opposite side is 12.5. And remember, perimeter, you're adding up all the sides. So you're adding up 11, 11, 12.5, 12.5. Alright, the next one is a proof. Sorry, I don't know why this is written twice. So basically, you can use those properties of parallelograms, and we're going to practice more of these next time, to show that you have triangles congruent, or maybe you're looking for corresponding parts, something to that effect. And there's really no like special property, like we had like reflexive property before, and substitution, things like that. There's no special names for these properties, you just kind of have to write it out. So we know for this one that opposite sides are congruent. So we know AB is congruent to CD. Then AD is congruent to BC. And that's because we know opposite sides in a parallelogram are congruent. We also know that since BD is a shared side, that is congruent to itself, and that's the reflexive property. So finally, these triangles are congruent by side, 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 because we had 3 pairs of sides. The next proof. So remember, you can always fill in what you're trying to prove and you're given. So this one, I've got EK is congruent to KG, and that's because these are diagonals that bisect each other, so that means KF and HK are also going to be congruent. It also says that opposite sides are congruent in a parallelogram because they're talking about EF and HG. So again, these two triangles are congruent by side, side, side. Alright, the next two are going to be using the properties of the diagonals, and we're going to practice these next time as well. So remember that the diagonals bisect each other, so that means you're going to have two sets of lengths that are equal to each other. Okay, so the first one, AE, AE, is going to be congruent to EC, because that one diagonal is being cut in half at E. So that means 3x equals y. DE is congruent to EB, because the diagonal is bisected. So that means 4x equals y plus 1. Well, the issue is I've got x's and y's in both equations. So that means I'm going to have to do a little substitution. So a little throwback to Algebra 1 here. So since 4x equals y plus 1, well, I know that y was the same thing as 3x, so I can plug that in its place. So then you've got 4x equals 3x plus 1, so x is going to equal 1. Okay. Once you've got x, then you can plug back in 3 times 1 equals y, so y is going to be 3 as well. The next one is going to be very similar, so I want you to try that one by yourself, and then you can continue with the video. Alright, so next one, when you set up your equations, again, AE is congruent to EC, so x plus 5 equals y, and then finally DE and EB were congruent, so 2x plus 3 equals y plus 2. Same thing, I can substitute in x plus 5 for my y. When you combine like terms, you have 2x plus 3 equals x plus 7. So when you subtract x and then subtract the 3 over, you get x equals 4. So when you plug back in x plus 5, or 4 plus 5 equals y, so y is going to be 9. The next two we're going to skip for today. We'll do those next time. For the last one, so we got to figure out which of the following are parallelograms. So we need to look at those lists of 4 properties. Plus, remember, we said the other way that you could prove that you have a parallelogram is that you've got one pair of sides that are at the same time both congruent and parallel. So I'll give you some time to circle whichever ones you think are parallelograms, and then you can continue the video. Alright, so hopefully you are able to see that diagonals bisect each other. So the first one works. Opposite sides are congruent, so the second one works. The next one, you've got this pair of sides that are both congruent, because they're 3, and they're parallel. If you were to find the slope, they're horizontal lines, so they would have a slope of 0. So you've got one pair of sides that are both congruent and parallel. For the next one, because the alternate interior angles are congruent, that means that we have parallel sides. So again, I've got one pair of sides that are both congruent and parallel. The next one does not work because I've got one set that is parallel, but the other is congruent. Okay, and we'll actually learn what type of shape this could be in a couple classes. So don't let that one be a trap for you here. All right, the next one, again, I've got one pair of sides that are both parallel and congruent. Okay, that one's the one that's most often forgotten. That's why you notice it was on here 3 times. Okay. So your homework and your classwork are posted on Blackboard, the same announcements page that you got the link for the YouTube video here, and also the classwork file that you used for your notes. Okay. So if you have any questions, you'll be able to ask us. We'll be able to go back over these next time in class. Okay. So go ahead and get started on your classwork and homework. If you finish early, just go ahead and find something quiet to do.